Okay, this problem, solve the system of equations by elimination. Show all work. Okay, for this one, I'm going to rewrite these problems. You can decide if you want to get rid of your x's or you want to get rid of your y's. So there's two ways you can do this by elimination. It doesn't matter which. I am going to get rid of my x's because one of the x's is a positive 6 and the other one's a negative 4. They're already opposite signs. And I'm going to turn them both into 12s because if I take the top equation and multiply it by 2, when you take 2 times this 6x, you will get a 12x. Of course, I have to multiply everything by 2. That's a bad x. You have to multiply the entire equation by 2. So 2 times 7y is 14y. And 2 times 96 would be 192. Then I'll take the bottom equation and multiply that one by 3, because 3 times the negative 4x would give it a negative 12x. And now they would cancel out. You can't cancel a 6x with a negative 4x. They don't cancel out. That's 2x. The goal of elimination is to eliminate somebody. And if they don't happen immediately, like the way they're handed to you, you have to make it happen. And you're simply using the product rule for solving equations. What you do to one side, you got to do to the other. You have to multiply everybody by that number. So the second equation, I'm multiplying by 3. That's going to be negative 12x minus 6x equals a negative 72. And now when I draw my line and I combine them, it's elimination by addition. Positive 12x and negative 12x is 0x. The x are gone. Negative 14 and negative 6 would be negative 20y. And 192 minus 72 would be a 120. And then it's just divide off the negative 20. Because negative 20 over negative 20 is a positive 1. And a positive divided by negative makes that a negative, and you'd get a 6. Now that is my y coordinate of my ordered pair. Remember, you're solving a system of equations, which means you're really looking for the point where they intersect. So we're just doing it with algebra. So now what I have to do is take that negative 6, pick a different color here, go blue again. I have to take this guy here and plug him back into one of the two original equations so I can solve for x. It doesn't matter if you use the top one or the bottom one. The bottom one has 3 negative numbers in it. I'm going to go to, I'm going to go and plug that into this y right here. So I'm going to have 6x minus 7 times, and I got a negative 6 for my y coordinate. And now, minus 7 times minus 6 makes this a plus 42. And then I would subtract the 42 from both sides. Eliminates here. I get 6x is equal to 54. And isn't that nice? Because when you divide by 6, 6 goes into 54 9 times. And that is my x coordinate. So the point where these two lines intersect is at 9, negative 6. I believe that's quadrant number 4, if you remember our quadrants. Anyway, that's a solution. If you do want to check your answer, you would have to put your x coordinate of 9 here and also here, and then your y coordinate of negative 6 here and here, and check it in both equations. Remember, you're intersecting two lines. There's only one point where they intersect. So that point has to check in both equations. And so if I did it for the top equation, this would be 6 times 9 minus 7 times a negative 6. That would be 54 plus 42, which is 96. Check. And then the other one would be, the second equation would be negative 4 times 9 minus 2 times negative 6. That's negative 36 plus a positive 12, which is negative 24. Yep, negative 24. So when I was checking them, just to show you that, this one I got 96, which matched this one. And I used yellow, blue. How about this color? And here I got negative 24, which matched that one. So, and that is elimination using the X's.